Okay, so let's also take a look at the audio item class. So I'm going to start by looking at our parent class, which is audio item. And I said before, I'm going to make this class abstract because I don't think it really makes sense to ever instantiate an object of generic type audio item, right? It's always going to be something more specific. It's going to be a song or a book or whatever it is, not just going to be a generic audio file. So I'm going to make this class abstract. And again, you'll notice that that doesn't change anything about my child classes. Before I make any of the methods abstract, my child classes are still totally fine as written. And even my driver program, I added in a couple of details here for some items that I put inside of a list, an array list rather, and this is totally fine. So again, the only thing I can't do is directly create an audio item file like this, or an audio item object rather. Price, number of seconds, yeah. So this is not allowed. Again, I can have the declared type be audio item, but not the instantiated type, not the actual type. So this is no longer allowed because audio item is abstract. Okay, so let's look at the methods in audio item. So I had my constructors, some getters and setters, and then I had play sample. And let me move my equals up. Okay, then I had my play sample method. This was the class specific method that I added. So the first question to ask is, if we were writing this class the first time through and writing our parent class, we'd say, are all of our child classes going to have some way of playing a sample of whatever that type of object is? And if the answer is yes, then we put that method in the parent class. And the answer for us is yes, right? We want to be able to play a sample of a song or play a sample of an audio book. Okay, so the answer to that is yes. So the method goes in the parent class because all child classes will have this functionality or behavior. Okay, so the second follow-up question is, are all of the child classes going to have the same implementation of this functionality? And the answer for us to that is no, right? We said a song was going to have a 30-second sample, and for the audio book, you were going to get to sample an entire chapter. So if that's the case, the method will make it abstract. So the method will be abstract because the child classes will implement the method differently. Okay, so to make it abstract, I just put that abstract keyword in there, get rid of the implementation, bracket to bracket, and put my semicolon. So now this method is abstract. That means that any child class that extends audio item must implement a play sample method. And if they don't, then that child class will also have to be declared abstract. Okay, so I can now take a look and let's see what's happened to my audio music item class. Nothing has happened, right? Because I do have my overridden play sample method, so we're fine there. And audio book item, same thing. I've got my overridden play sample method, so now I've got that functionality that I agreed to have because it's abstract in the parent class. I've implemented it in the child class. And if I go into my tester here and I can iterate through my array list, so here what I've got is an array list where the declared type of every item in the array list is audio item. So this is the declared type. But then the actual type of the various things that I've added to my array list are different. There's some music items, some book items, and so on. Okay, so I could now loop through for every audio item in my item list, and I could invoke the play sample method. And again, from the compiler's perspective, it says, what's the type of this object? Well, the type is audio item, and then it says, does this method exist in the audio item class? And it goes to that class, and yes, it does. Compiler doesn't care that it's abstract, just cares that it's there. At runtime, the Java virtual machine is going to say, okay, I know the declared type is audio item, but what's the real type? If the real type is audio music item, this is going to be the version of the method that I'm going to invoke. And if the real type is audiobook item, then this is going to be the version of the method that I'm going to invoke. Okay, so if we run this, first of all, we'll see it's allowed to compile, it's allowed to run, and we'll get the appropriate output. So we'll get 30 seconds of each one of our songs, we'll get one chapter out of each one of our books. Okay. So again, this is sort of a shorter little example, but another example of using abstract classes. Again, the key idea is you want your abstract class to have common functionality, common characteristics that are shared by all your child classes. That's true of any parent class, but then whether or not you make it abstract depends on whether you'd actually ever want to instantiate objects of that type. And if the answer is no, that type is too general, then you make it an abstract class. Once you make it an abstract class, you have to decide which methods should be implemented and thus inherited by all child classes, and which methods should be abstract. If all child classes are going to have the exact same implementation of a method, implement it in the abstract parent class. If any method describes functionality that you want all the child classes to have, but it's going to differ how they implement it, then put the method in the parent class, but make it abstract.